Okay, so I'm going to share my screen with all of you, and I hope you can see me as well. So good evening to all my dear students. I hope you all are having a really good day, and I hope you enjoy your past week also. So I want to make an announcement, which is now you are listening to a recording, Putala. I hope you can understand that. So that is because I am unable to attend the Saturday class. Therefore, I have prepared this recording for all of you to listen. Just like the previous classes, you can stay in the class, listen to this recording, and write down the notes. So I will be giving you notes to write down, just like earlier class. So therefore, you can take your enough time and write down the notes. And if you come up with any question in the middle of the class, and if you feel like you don't understand something, you can please write it down in the book. Okay, please write down that question in the book so I can ask it. You can raise that question within the next class. Okay, next week class, which I will be there. Okay, this is only recording for this time only because I have unavoidable um, situation to attend. Okay, so today we have to start talking about reverberation. Reverberation. So, what do you know about reverberation? So we have previously discussed about the lesson echoing. If you can remember, we discussed what is known as echoing, isn't it? That is a second hearing because of the reflection of sound after the first one. It is known as an echo. So today we have to talk about reverberation. So there are some instances in an auditorium or a cinema hall that the sound emitted by the loudspeaker is not clear. The reason for this is that the echo generated by the reflection of sound is heard before the initial sound fades off from the ear. I think last week we wrote down the definition for reverberation also, isn't it? So the persistence of sound for a long time because of the disability to distinguish. And the original sound and the echo sound is known as reverberation. I can remember some student asked what is known as distinguished. And I told you, හඳුනා ගැනීම පුතේ වෙන්කර හඳුනා ගැනීම. So I have discussed about this one. So today we will start from the new part, which is known as refraction of light. Refraction of light. And before coming to refraction of light, you can see what are the instances where this reflection of sound is used. What are the instances where we use this reflection of sound in our day-to-day life and in professional scenarios? So ultrasound scanning, you might have heard about this. What is known as ultrasound scanning? Ultrasound wave is used to observe the shape of internal organs. අපේ ඇඟ ඇතුලේ තියෙන organs. Internal organs වල shape එක determine කරන්න we are using ultrasound scanning. Ultrasound waves are generated by a machine and are aimed at the relevant organ from outside of the body. So ultrasound waves that reflect from the organ are received by the machine, and those waves formulate the external appearance of the relevant organ on the screen. So this is used in womb, examining the womb of a pregnant mother. So you can see when this equipment, you can see it's like a small cup-like structure. When it is placed on the mother's womb, on the mother's belly, it will give the image of the mother's womb, inside womb on the screen. You can see in this picture. They are giving the picture of the inside womb on this picture, on this screen actually. Womb of a pregnant mother is being subjected to ultrasound scanning. How the fetus developing in the womb is seen in ultrasound scanning. So this is a scenario where reflection of sound is used. Then finding the depth of the ocean bed. This is also again another scenario. Okay, this is also again another scenario where reflection of sound is used. Then හිතන්නකො පුතේ. නැව්වල ඉස්සරහට තියෙන obstacles බලා ගන්න. මොන වගේ obstacles තියෙන්නේ? ඉස්සරහෙන් ලොකු obstacle එකක් තියෙනවද අපිට පේන්නේ නැතුව මුහුද ඇතුලේ. අන්න ඒ වගේ දේවල් බලා ගන්න මේ sonar system එක. You might have heard about it. Sound navigation and ranging. Sonar system is also used as a result of reflection of sound. So it is important to know the depth of the ocean bed in navigation. Reflection of ultrasound wave is used for this purpose. What are they doing? They are going to send the ultrasound wave from the ship to the bottom of the sea. Okay, from the ship to the bottom of the sea. And you know, it will hit on the particular obstacle and it will take another time to come back. I return වෙන වෙලාවක් යනවනේ. Wave එක ගිහිල්ලා obstacle එකේ වැදිලා ආයි එන්න යන වෙලාව. Right? Wave එක ගිහිල්ලා obstacle එකේ වැදිලා ආයි එන්න යන වෙලාව තමයි අපි බලන්නේ. Okay, actually there are different kind of methods to measure. You can measure it from the time, you can measure it from the distance taken, like that, it depends. So there is a particular system and an equipment used for this purpose. Okay, it is known as echo sounder. Echo sounder. So remember these instances. They will be helpful. And the last one. This is an animal. You can see it is a bat. කොහොමද මෙයා ගමන් කරන්නේ රැට? කොහොමද මෙයා පියාඹන්නේ? For bats to identify obstacles at night. කොහොමද මෙයා යන්නේ? Reflection of ultrasound waves help nocturnal animals. Who are known as nocturnal animals? Think for a second. Who are known as nocturnal animals? ඒ කියන්නේ රැට සැරිසරන ජීවීන්. නේද? Nocturnal. They are very active at night, like bats to identify obstacles at night. Ultrasound waves emitted by them reflect after bouncing on the obstacles. According to the time taken for this, they can determine the distance to the obstacle. Okay, so මෙයාගේ echo sound එක දීලා obstacle එකේ වැදිලා ආයෙ එන්න යන වෙලාවෙන් තමයි මෙයා දැනගන්නේ මෙයාගේ ඉස්සරහින් තියෙන්නේ මොකද්ද කියලා. මෙයාගේ ඉස්සරහින් තියෙන්නේ මොකද්ද කියලා මේ බැට් දැනගන්නේ, මේ වවුල දැනගන්නේ එයාගේ echo එක ගිහිල්ලා obstacle එකේ වැදිලා ආයෙ එන්න යන වෙලාව. Right? Okay. So I hope you understood these 3 points. These are the 3 instances in your syllabus which they have given for you to understand about instance where reflection of sound is applied usefully. So can you please write down this topic right now? So put today's date and start writing the note. Add the dinner and start writing the note. This is the topic you have to write. And after writing the topic, you only have to write the points, just the instances. First one, ultrasound scanning. Second one, finding the depth of the ocean bed. Second one, finding the depth of the ocean bed. And the last point, which is for bats to identify obstacles at night. For bats to identify obstacles at night. For bats to identify obstacles at night. Right. These are the 3 instances where reflection of sound is applied usefully. You can write down these 3 points, that is enough. No need to write long sentences for 1 by 1, okay? Just write down these 3 points. Okay, quickly write down. Okay. I hope you have finished. You just have to write down few small points. Just 3 points you have to write down. First one is ultrasound scanning. Second one is finding the depth of the ocean bed. Third one is for bats to identify obstacles at night. For bats to identify obstacles at night. Okay? So those are the 3 points you have to write down. So I will give just 1 more minute in case if somebody is still writing. Okay, so I hope you are finished. I'm going to erase. Right. Now we are coming to the most important topic. One of the most important topics in your syllabus. That is refraction of light. So what do you know about refraction of light? What do you know about refraction of light? So you have to think very well. Earlier we have learned about what is known as reflection. So what is exactly the difference between reflection and refraction? Think by yourself. What might be the difference between reflection and refraction? You know, reflection is where a light ray hit on a surface and it goes back with the same angle. A light ray hit on the surface and it goes back in the same angle. That is reflection. You know, angle of incidence is equal to the angle of reflection, isn't it? There is incident ray and reflected ray. But in refraction, it is different, children. The refracting ray is not going in the same angle. Okay. Refraction happened between two mediums. So you can remember reflection happened in the same medium. For an example, if a light ray comes and hit on a plane mirror, it goes back with the same angle. That is happening in the air medium. Atmosphere කියන්නේ වෙන්නේ scenario එක. So it happens in the air medium. Right? But there are instances where the light ray pass through some mediums. Okay, so you have to think about this. What might be known, what is known as refraction? So let's see. Okay, now I want your full attention. I hope you have written the previous note already. So let's come to this topic. Okay. So refraction of light. When light is traveling through transparent medium, it travels rectilinearly. Linear කියන්නේ කෙලින්. When light is traveling through transparent medium, it travels rectilinear. Now let us consider an instance that a light ray entering from one transparent medium to another transparent medium. Can you see? Two mediums are involved here. Two mediums are involved here, not like in the reflecting, right? So let us do the activity for studying this phenomenon. You can see activity 14.10. What are the things you need? Go through this. A beaker of water, some soap, an electrical torch or a laser torch. Method. Mix some soap in water in the beaker without allowing to form lather. පෙන එන්නේ නැති වෙන්න වතුර සබන්ටි mix කරගන්නවා පෙන එන්නේ නැති වෙන්න, right? direct thin inclined beam. පෙන හැදුනොත් පුළුවන් ඒ පෙන් ටික අයින් කරලා විසික් කරන්න. එතකොට සබන් වතුර ටික විතරයි තියෙන්නේ පුතේ. Okay, I hope you understood. Direct a thin inclined beam of light using the electrical torch or laser torch. Okay, I think it's better if you can use a laser torch because you can see this scenario very nicely because you know laser torch consists only of one light ray. Observe how the path of light beam changes when it enters into water. Then menna thiyena laser torch එක and this is the thin light beam, right? Soap mix water thiyena. දැන් මේ අපිට පේන්නේ උඩින් ඉඳන් බලනකොට මේ යන විදිය, right? Directing the light beam perpendicular to the water surface. මොකද්ද කරන්න තියෙන්නේ? soap water තියෙන beak එකක් අරගෙන උඩින් torch light එක අල්ලන්න තියෙන්නේ, right? torch light එක උඩින් අල්ලද්දී අපිට කොහොමද එළියෙන් පේන්නේ? බලන් ඉන්න කෙනාට එළියෙන් පේන විදිය. පැත්තෙන් from the side. Not from the above, උඩින් බලන විදිහ නෙවෙයි. උඩින් බලනකොට අපිට perpendicular line එකක් පේන්නේ. Not that. From the side. What are you going to observe? See, thin beam of light is there. If the light beam is traveling in the first instance, if it is not traveling like this, when it enter to the mixed water, මොකද වෙලා තියෙන්නේ මෙතන light ray එකට? Can you see ඒක bend වෙලා නේද? ඔන්න මම දැන් normal එක අඳිනවා. Now you know what is known as normal. Normal එක දන්නවනේ. Normal එක ඉගෙන ගත්තා reflection වල. This is the normal line which is perpendicular. And this is the angle of incidence, right? මේ තමයි angle of incidence. But look at the angle of refraction. පුතේ it is small. එයාව bend වෙලා ගොඩක්. දැන් හිතන්නකෝ if the angle of incidence, if I name it as simple I, if this is simple R, angle of incidence is bigger than angle of refraction. Why is that? They are two mediums. This is air medium above the water. This is water medium, liquid medium. Soap water medium. They are two mediums. ඒකයි මේ light ray එක bend වෙලා යන්නේ. එතකොට හොඳට මතක තියාගන්න refraction එකක් තමයි මෙතන වෙලා තියෙන්නේ. Refraction කියන්නේ මොකක්ද එහෙනම්? When a light ray is passing from one medium to another transparent medium, how it is going to bend? දැන් reflection එකේදී ආයෙ ඇවිල්ලා ඒ angle එකෙන් හැරිලා යනවානේ. Refraction එකේදී එහෙම නෑ පුතේ. ඒක ඇතුළට යනවා and also it will bend. Bend වෙනවා. Right? සමහරක් විට incidence angle එකට වඩා refracted angle එක ලොකු වෙන්නත් පුළුවන් පොඩි වෙන්නත් පුළුවන්. It depends on the medium. Okay? It depends on the medium. So did you understand? Everybody? Did you all understand what happens in here? Can you see when the light ray transfer from air to soap water from one medium to another medium, this angle is bending. It gets different. Initially, if the angle was, incidence angle was like, let's say, 60-degree angle of refraction is about 30 degrees. It's different. This is refraction, children. This is refraction. I hope you understood this very well, right? So now you have a work to do. Please write down the topic, our main topic. Refraction of light. Refraction of light. Our main topic, refraction of light. Okay, write down this sentence. When light is traveling through a transparent medium, it travels rectilinearly. Okay. Then write down, consider an instance that a light ray entering from one transparent medium to another transparent medium. And I want all of you to draw this diagram. Draw this diagram, the first diagram and the second diagram. When you observe from the above, when you observe from the side. Please write it down. quickly draw these two diagrams. So you have to mention the bending very nicely, okay? And see, like this, if you want, you can mention the normal also. Normal should be 90-degree angle. Like this. Okay, if you want, you can mention this is the air medium. This is the soap water medium. Quickly draw this. Okay, so I hope you have finished. Right? You just have to write down these two sentences and the diagram. So make sure you label it. Laser torch, thin light beam, soap mix water. Okay, I hope you have finished. If you want, I can give 1 more minute. Just quickly write down. Right, I'm going to erase. Carry out the activity changing the inclination of the thin beam of light. That means the angle of incidence. You have to change. Discuss your observations in the classroom. Answer the following questions while engaging in the activity. What are the two transparent media that the thin beam of light traveled through? At what place did the beam of light bend? What is the reason for mixing soap into water? What happens when light is directed perpendicular to the water surface? You have to answer these questions by thinking. What are the two transparent media that the thin beam of light traveled? I told you already, it is between air and soap water, right? And then at what place did the beam of light bend? That means you have to, like, first of all, you can try from keeping the laser torch from this here. මෙතන කෙලින්ම උඩින් 90 degree angle එකෙන්ම තියලා බලන්න පුළුවන් මොකද වෙන්නේ කියලා. ඊට පස්සේ angle එක එන්න එන චුට්ට අඩු කරනවා. මෙතනින් තියනවා, මෙතනින් තියනවා, මෙතනින් තියනවා, like, right? ඕන මෙතනින් තියන්නත් පුළුවන්. එතකොට 0 angle, right? තියලා බලන්න පුළුවන් මොකද වෙන්නේ කියලා. And then what is the reason for mixing soap into water? Because you want to make a media. Then what happens when light is directed perpendicular to the water surface? Okay, let's discuss these points. Then I will show you a video. In the activity 14.10, light rays have traveled from one transparent medium, which is air, into another transparent medium, which is water, or even soapy water is fine. The surface where the two media come into contact with each other. මේ දෙක එකට එකතු වෙන තැන. මොකක්ද ඒ තැන? The surface where the two media come to contact with each other is known as interface. What is interface? This is the interface. මේක තමයි interface එක කියලා කියන්නේ. Right? Then light travel from one medium into another medium through the interface. Yes, it may be clear that always change of direction of light occurs at the interface. It is important to mix soap into water to see the beam of light in water. Okay, it is important to mix the soap water because if you need to see the beam of light more clearly, you can add soap water. The change of direction of light when traveling from one transparent medium to another transparent medium is known as refraction of light. See the difference between reflection and refraction. දැන් ඔයාලට කියන්න පුළුවන් වෙන්න ඕනේ. මොකද්ද වෙනස කියලා? reflection එකේ refraction එකේ මොකද්ද වෙනස ඇහුවොත් දැන් ඔයාලට කියන්න පුළුවන් වෙන්න ඕනේ. Okay? The change of direction of light when traveling from one transparent medium into another transparent medium. The beam of light directed perpendicular to the interface do not occur refraction. The beam of light directed perpendicular to the interface do not occur refraction. කෙලින්ම perpendicularly 90 degree angle එකක් නැතුව 90 degree angle එකකින් laser torch එක අල්ලන් හිටියොත් right to the interface like this to the interface with a 90 degree angle. If you keep it like that, refraction will not occur. Okay, refraction do not occur. During refraction, the ray that is reaching the interface is the incident ray. එක දන්නවා incident ray ගැන කලින් ඉගෙන තියෙනවා in reflection. The ray that travel after refraction is the refracted ray, not reflected, not reflected. Reflected is in the reflection. The angle that travel after refraction is refracted ray. And the point of the interface, the point on the interface where the incident ray falls is the point of incidence, and the normal line also can be constructed at the point of incidence. Okay, this is the diagram. Before coming into the diagram, shall we write down the note? And then I will show you the video also. So let's write down the note. Write down this. You can even write down that this by using another color, or you can put a star point. Then the next one, another special point, and please write down these 4 points of refraction. Write down the underlined sentences and write down these 4 points which I have put a tick. So quickly write down. I will give you enough time. Okay? I hope you are writing down. So I think still you need some more time. Okay, so I will give like 2 more minutes or 1 more minute for you to write down. Okay, quickly write down. Then we can watch the video. We can draw the ray diagram, the relevant ray diagram. Right. I'm going to erase the screen. Okay. So now we will come to the ray diagram. Look at this nice ray diagram. The way of refraction occurs when a light ray enters from air to water can be shown by a ray diagram as in the figure. So look at the normal. This is the normal line. You know about it already. කඩේට තමයි normal line එක. නේද පුතේ? And then this is the angle of incidence. See? Angle of හැමතිස්සෙම angle of incidence බලන්නේ normal එකත් එක්ක ray එක ගාවට තියෙන angle එක. Okay? මේකත් එහෙමයි. normal එකත් එක්ක ray එක ගාවට තියෙන angle එක. Okay? Not from here to here. Okay? Then interface එක තියෙනවා. And look at the two mediums, air and water medium, incident ray and the refracted ray. So, can you please draw this? Can you please draw this quickly? Please draw the ray diagram and label it. Okay. Did you draw it? All right. So I hope you have finished drawing, isn't it? So if you have any question, please write them down in a book. Okay. So you can raise that question in the next class. Okay. In the next class. So can we watch a video regarding this? Give me 1 second. I will stop sharing. I have taken a video. Right, there is a video. I will share my screen. So now I hope you can see my screen. Even when you're watching the video, if you come up with any question, you can write it down and ask me in the next class, okay? So watch this video now.
What can happen when a beam of light is incident on the surface of any object? When a light beam is incident on the surface of any object, a part of the light can be reflected by the object, a part of the light can be transmitted. That is, it may pass through the object and get out from the other side, and a part of the light can also be absorbed by the object. The amount of light reflected, absorbed or transmitted depends on the material that the object is made up of. If an object is opaque, then it will absorb and or reflect most of the light back. If it's transparent, more light will be transmitted. Can you think of examples for these two? The surface of a mirror is shiny and opaque, and most of the light rays are reflected from it. On the other hand, glass is an example of a transparent object. It will transmit most of the light. So what is refraction of light? Here's how we define it in simple words. It's simply bending of light when it travels from one medium to another. Yes, if it is incident at this angle, then it goes through at another angle. Now this is not the exact definition, as there are a few technicalities involved. Let me explain it to you. Consider a transparent object kept here, say a glass slab. Suppose light traveling through air is incident obliquely on the surface of the glass. What do I mean when I say obliquely? It means slant. It implies that the incident ray is neither parallel nor at a right angle to a specified line. Now this light will bend at the boundary of the two media. Here, the two media are air and glass. This bending of light at the boundary of the two media is what we call refraction of light.
Okay, in here you can see, children, they have used the air and glass medium. Earlier we were talking about air and water medium, but in this video they are showing the refraction of light ray between air and glass medium. Can you see in here also angle of refraction? Angle of refraction is smaller than the angle of incident. Incident ray is bigger than the refracted ray. Okay.
Light. We see that at this point the light bends. It's not going straight. What are these two mediums called? The medium from where the light is incident is called the incident medium, and the medium where refraction occurs is called a refractive medium. Similarly here as well, the light is traveling from one medium to another medium. It's from glass to air. And here also it is incident at an angle. Since we know that air is a transparent medium, light bends at this boundary and travels through air. So light refracted at these 2 points. Let us draw a line perpendicular to the surface at this point of incidence. This line is also called a normal. What is this angle called? It's called the angle of incidence and is denoted by the letter I. It is an angle made by the incident ray with the normal. And this is the angle made by the refracted ray with the normal. It's called the angle of refraction R. Now there might be various questions that you have. Why does refraction occur? Why does light change its direction after entering another medium at an angle? Why does incident light have to be slant in order to change its direction? Can the refraction occur if the light enters perpendicular to the surface? We will answer all these questions in the coming videos.
Right. I hope it was very clear. I hope it was very clear, and I hope you got an understanding from that one, from that video. Now we will again come to the lesson. Right. So there is something for your extra knowledge. They have said that the velocity of light, what is velocity? Velocity is something like speed, but not speed. Speed and velocity are two things. But if I use the speed term, you understand that, no? So, speed of air in a vacuum is 3 into 10 to the power 8. Sorry, speed of light in air. Speed of light in air is 3 into 10 to the power 8. Speed of light in water medium, 2.25 into 10 to the power 8. Speed of light in glass, 2 into 10 to the power 8. Can you see? It's 10 to the power 8. 10 8 බල. කියන්න හිතන්න කොච්චරක් ලොකුද කියලා. ස්පීඩ් එක මාර ඉක්මා. Right? So refraction of light in a glass block, that is the next activity we are going to talk about. Let us study how a narrow beam of light, a pencil of light, refract when directed into a glass block. මේ light ray එක glass block එකකට direct කරාම කොහොමද refract වෙන්නේ අපි බලමු. You have to take a glass block, a sheet of white paper, 4 pins, an electrical torch or a laser, a pencil and a ruler. Spread the sheet of white paper on the table and place the glass block on it. Direct an inclined beam of light onto the glass block as shown in the figure. See, this is the incident ray. මේ තියෙන ලස්සන ඇඟල. ඇවිල්ලා glass block එකේ වදිනවා. මෙතනක් තියෙනවා නේ. ඇවිල්ලා glass block එකේ වදිනවා. Then you can see the refraction. Glass block එක through වෙන refraction එක. මේ තියෙන fix the 2 pins in the path of the incident ray and the other 2 pins in the path of light ray that travel away from the block. එතකොට ඔයාලට මෙහෙම වැඩකුත් තියෙනවා. pins දෙකක් fix කරන්න ඕනේ මෙතනයි මෙතනයි. Right? කොහොමද මේ light ray එක යන්නේ කියලා බලා ගන්න තමයි අපි මේ fix කරන්නේ pin. ඔයාලට බලා ගන්න පුළුවන් මේ දෙක parallel. A light rays එක parallel. We will come to that point. So in here you can see this is a refracted ray within the glass block. And then it again comes out with the same angle. So we can say this is parallel to this. ඇයි මොකද දෙකම එයානේ. දෙකම එයා medium එකේ වෙන්නේ. Right? Sketch the position of the glass block using the pencil. Remove the glass block, the pins and the torch. Complete the ray diagram. That's what you have to do. Right. Then, okay, can you write down refraction of light in a glass block? Refraction of light in a glass block. Sorry. Wait, I will stop share and share again. Refraction of light in a glass block. And can you please write down activity 14.11? Draw this ray diagram. Okay. Draw that one. Draw that ray diagram so you will understand. Right. I hope you have finished drawing, isn't it? So, okay. Now we have to come to effects of refraction of light. Effects of refraction of light. What are the effects? Actually, this lesson we can finish it today within the class, so it's easy. Effects of refraction of light. We will talk about this now. Let us consider briefly, so you can write down the topic, okay? Effects of refraction of light. You can write down the topic. Let us consider briefly some phenomena that can be seen in day-to-day life due to refraction of light. මොනවාද මේ අපිට එදා දවසේ දකින්න හම්බෙන දේවල් මේ refraction නිසා. Apparent elevation of the bottom of a pond or a container of water. අපිට සමහරක් වෙලාවට pond එකකට එහෙම ඔළුව දැම්මොත් වාජනයක් ඇතුලේ තියෙන මොනවා හරි එළවලු හරි මොනවා හරි බලන්න වතුර ඇතුලේ තියෙන දේවල් බලන්න ඔළුව දැම්මම අපිට පේනවා නිකන් ඒක ඉස්සිලා වගේ. තියෙනවා ගොඩක් උඩින් තියෙනවා වගේ පේන්නේ. Why is that? Let's see what is that. What's the reason behind it? That is because of the apparent elevation. Apparent elevation of the bottom of the pond or a container of water. Right, there is an activity. Okay, I'm going to go through it. I'm going to read it for you. A tall glass tumbler or a beaker, water, a coin or a nail, and a pencil. What is the method you have to do in here? Put the coin or the nail into the glass tumbler or the beaker. Fill it with water. Observe the coin or the nail from above. There may be beaker water පුරවලා කාසියක් දාන්නයි යන්නේ. Mark the apparent bottom, the coin or the nail, when viewed from top. උඩින් බැලුවාම BK එකේ කොතනින්ද මේ coin එක පේන්නේ? You have to mark that. උඩින් බැලුවාම මේ coin එක BK එකේ කොතනින්ද පේන්නේ? You have to mark that. When viewed from the top, on the side, පැත්තෙන් බලුවම කොතනින්ද පේන්නේ? පැත්තෙන් බලනකොට කොතනින්ද පේන්නේ? උඩින් බලනකොට කොතනින්ද පේන්නේ කියලා mark කරගන්න ඕන. Now measure the real depth. ඇත්තම depth එක මොකක්ද? අපි දන්නවා water column එකත් එක්ක බලද්දි beak එකත් එක්ක බලද්දි අපිට පුළුවන් real depth එක ගන්න. water column එකේ depth එකනේ real depth එක. ඒ කියන්නේ ඇත්ත ගැඹුර. ඇත්ත ගැඹුර තමයි මේ තියෙන්නේ. ඇත්තටම උඩ ඉඳන් පල්ලෙහාට වතුර උඩ surface එකේ ඉඳන් coin එක ගාවට තියෙන දුර තමයි මේ තියෙන ඇත්ත දුර. හැබැයි අපි උඩ ඉඳන් බලනකොට අපිට පේන්නේ නිකන් coin එක මෙතන තියෙනවා වගේ පුතේ. ඒ තමයි බොරු දුර, apparent depth. බොරු දුර. Right? So I hope you got an idea. Coin එකක් දානවා නැත්නම් nail එකක් දානවා. උඩින් බලනවා. උඩින් බලනකොට අපිට පේන්නේ නිකන් මෙතන තියෙනවා වගේ coin එක. එතකොට water surface එකේ ඉඳන් මෙතනට තියෙන බොරු දුරක්නේ. ඇත්තම දුර බලනකොට water surface එකේ ඉඳන් පල්ලෙහාට මෙතනට වෙනකන් that is the real depth. So real depth, apparent depth. That's the difference. It is clear that they are saying observable depth. It is clear that the observable depth or the apparent depth when viewed from top is always less than the real depth from the water surface to the bottom. හැම වෙලේම එක ගන්න අඩුයි. observable depth එක නැත්නම් apparent depth එක. ඒ කියන්නේ බොරු depth එක. අපිට නිකන් බොරුවට පේන උඩට ඇවිල්ලා වගේනේ. අන්න ඒ depth එක හැම වෙලේම අඩුයි real depth එකට වඩා. ඇත්ත ගැඹුරට වඩා හැම වෙලේම අඩුයි. Apparent depth is always less than the real depth. Okay? From the water surface to the bottom. So it is important to think carefully before step down into well or a reservoir because real depth of it is more than the apparent depth. එතකොට අපි දැන් හිතන්නකො පුතේ වැවකට ලේක් එකකට බහිනකොට අපිට පේන්නේ නිකන් ගලක් නැත්නම් bottom එක පතුල නිකන් ළඟ තියෙනවා වගේ right? අපි කකුල දානකොට අපිට පේන්නේ මේක ඉච්චර ගැඹුරු නෑනේ ළඟනේ තියෙන්නේ. වතුර උඩින් නම් බලනකොට අපිට පේන්නේ නිකන් උඩින් තියෙනවා වගේ. No, it is the apparent depth. ඇත්තරම කකුල බදාලා බලද්දි තමයි ගොඩාක් එක ගැඹුරුයි කියලා අපිට තේරෙන්නේ. real depth එක තේරෙන්නේ එතකොටයි. Right? So I hope you understood the difference between real depth and apparent depth. If you have any question, as I always say, you can write it down in the book and ask me that point in the next class. Okay? So now you have a work. Effects of refraction of light කියලා ලියාගෙන write down this subtopic also. Then activity 14.12 subtopic. Please draw this diagram, label it, mark the apparent depth and real depth correctly. Mark the apparent depth and real depth correctly, Pute. Okay, mark it correctly. Okay, so make sure you label the diagram and make sure you are putting the apparent depth and real depth correctly, okay? Okay, so have you finished drawing? I hope you have finished drawing. Have you finished drawing? Okay, so shall I erase the screen and give me 1 second? to show you the video. Okay, give me 1 second. Wait. Wait. Okay, this video is good. We will watch this one. If you have any question, you can raise it. You can write it down.
Let's start with a very simple experiment. Put a coin in an empty cup. Position yourself in such a way that the coin is not visible. Now slowly add water into the cup. Slowly you will start to see the coin. Observe that the coin is completely visible now. Why do you think this is happening? The coin isn't moving. Rather, it just looks like it has moved up because of a phenomenon known as refraction. Let's take a closer look. We see objects only if light hits them and the rays reflect or refract off them and reach our eyes. In our experiment, the rays of light hit the coin and bounce to our eyes after refraction. When light rays travel from a dense medium to a rare medium, that is from water to air, they are refracted away from the normal at the surface of water. Then, when these refracted light rays enter our eyes, they create the illusion that the coin lying at the bottom of the cup is closer to us than it really is. In reality, we can't observe the zigzag path that the rays of light are taking. Our eyes always perceive rays of light as a straight line. We can draw a line to represent the path of a refracted ray. We can also draw a line to show the path from our eyes back to the refracted object. The point where these rays meet is where the coin appears to be. In reality, the coin is at the bottom of the beaker, but because the light bends when it hits the water, the image of the coin is formed above the actual position of the coin. This is why we are able to see the coin upon pouring water in the cup. The distance from the actual position of the coin in a transparent medium, like water to the surface of water, is called real depth. Can you guess what apparent depth is? The distance from the image of an object in a transparent medium, like water to the surface of water, is called apparent depth. This is why a swimming pool appears less deep than it actually is. Now, let's have a look at critical angle. When an incident ray moves from a dense medium like glass to a rare medium like air at an angle other than 0, the refracted ray bends away from the normal. Remember that normal refers to an imaginary line which is perpendicular to the surface of a medium. In this case, the angle of refraction is greater than the angle of incidence. What happens when the angle of incidence increases? When the angle of incidence increases, so does the angle of refraction. If the angle of incidence is gradually increased, a point comes when the refracted light travels along the boundary of a dense medium and the angle of refraction becomes 90 degrees. When the angle of refraction is equal to 90 degrees, The angle of incidence is called the critical angle. This is denoted by the letter C. The critical angle of glass is 42 degrees, and that of water is 49 degrees. Time for an exercise. Take a few minutes and discuss with your friends.
Okay, in here, find the image of the fish and label the real and apparent depth when an observer is looking at the fish from the top. So you already have an idea about it. I'm not gonna go beyond that. Okay, so I hope you got a really good understanding from that one. We will come to the examples. Okay. Right, for extra knowledge. Birds like kingfisher observe fish in water a little above than where they actually are. But those birds have an idea of the real depth and depth to the fish. But they have an idea, right? Kingfisher knows where exactly the fish is. Fish is located. Amazing, no? See how their eyes are built according to the nature. Very beautiful. Now, pencil dipped partially in water seems to be broken at the water surface. බලන්න මේ නිකන් පැන්සල කැඩිලා වගේ. වතුර ග්ලාස් එකකට දැම්මම. මේක නම් ගෙදර කරලත් බලන්න පුළුවන්. Do this and see. Right. Okay. So why is that? A pencil which is partially dipped in water seems to be broken at the liquid surface when viewed from a side. The reason for this is the refraction of light when it comes from water to air. Right? එක පොඩි idea එකක් තියාගන්න. Then refraction of white light through a prism. Prism එකකින් light එක යන විදිය අපිට discuss කරන්න තියෙනවා. Right? Then this is the exercise. A wonderful occurrence can be observed when the white light passes through a glass prism. Glass prisms දැකලා තියෙනවද? මොන වගේද? What do they look like? Prism එකක්, pyramid එකක් වගේ. It is in triangular shape. It looks like a prism made of glass. Glass වලින් හැදිලා තියෙනවා. So you have to take a prism and a white screen, a piece of cardboard and a plane mirror. Keep the glass prism on the table. Direct a narrow beam of light onto the prism using plane mirror and the piece of cardboard. Let the light that pass through the prism fall onto the screen. Discuss the reason for your observation in the classroom. මොකද්ද වෙන්නේ? Can you see? Rainbow colors එනවා. Prism එකක් through light ray එකක් ගියාම rainbow colors එනවා children. Okay? A spectrum of 7 colors can be observed. Separation of white light into 7 colors. සුදු පාට 7ක් වෙනවා prism එක through ගියාම. Due to refraction, ඇයි ඒක වෙන්නේ? Due to refraction is the reason. Colors of the spectrum are red, orange, yellow, green, blue, indigo and violet. ඒක අනිවාර්යෙන් පාඩම් කරන්න ඕනේ. අපි කියනවා සිංහලෙන් මේ වචන ටික මේ පාඩ ටික මතක නැත්නම් පාඩම් කරන්න. ඒ කියන්නේ මතක හිටින්නේ නැත්නම් you can use this. I can remember I use this to remember the colors. Run තැඹිලි කඩන කොල්ලා නිල් ලිබ්බෙක් දකි. මොකද run තැඹිලි කඩන කොල්ලා නිල් ලිබ්බෙක් දකි. ඒ තමයි පාට ටික. run රතු. තැඹිලි කඩන කිව්වහම කහ. කොල්ලා කොළ. නිල් ඉබ්බෙක් indigo දකි දම් පාට. Right? So colors of the spectrum are red, orange, yellow, green, blue, indigo and violet respectively. So you have to study that. Separation of white light when passing through a prism is known as dispersion. Okay, so I want all of you to write down activity 14.3. And I want you to draw this diagram. 7 colors tika ඇඳගන්න පස්සේ, but you have to draw the prism and the white light and everything, okay? And write down these sentences. මේ colors අනිවාර්යෙන් පිළිවෙලට පාඩම් කරන්න ඕනේ. That is a must. අහන්න පුළුවන් විභාගෙට. ඔයාලන් හිතයි දැන් පුතාට හිතන්න පුළුවන්. rainbow color සමහරු නෑනේ මට මතකයි. ඒ උනට පිළිවෙලට මතක තියාගන්න. පාටවල් ටික දන්නවා ඇති. But you have to remember them in order. Okay, so write down this. Okay, I hope you have finished. Time is enough, right? Time is enough. So, okay, this is there something for your extra knowledge also. You can go through it. And the occurrence of rainbow. It is another elegant phenomenon, very beautiful, a very nice scenario that occurs due to refraction of light, right? When the bright sunlight with mist or drizzle, rainbow can be frequently observed. Okay. මේක වෙන්නේ internal reflection හින්දා. light ray එක වැටිලා water droplet එකකට ඒක ඇතුලේ internal reflection වෙලා then it gives the 7 colors. That's how it happens. Okay, so we have successfully finished the lesson. Now you have a homework. You already know, I think, what it is. You have to do the exercise and come. That is your homework because I'm going to discuss it within the next week. Okay, I'm going to discuss it in next week. Therefore, you have to listen to the recording very well, so which I'm already doing. So you have to do the exercise and come, so we can discuss it next week. So I hope today's session was very clear. If you have any question, you can write it down and send it to me, or you can ask it in the next class. I hope all of you had a great lesson today, children. I hope it was clear as well. So we have successfully finished the refraction lesson. Okay, so that is the end of the recording. I will see you all next week. And until then, have a really good week and stay safe. Okay, good night, children. Take care. Bye-bye.